Hello, we are team number 3, and this is our evidence number 2, resolution of problem situation. Problem situation is that a family business is dedicated to the production of ethyl acetate, and the owners of the company have found that eliminating the amount of water produced could favor the production of ethyl acetate, but they do not know if this will work. The owners of the family company that produces it want to optimize the process to increase their profits. Therefore, they are seeking for our team's knowledge to do so.
Ethyl acetate, with the chemical formula shown here, is used as an ingredient in different commercial products such as nail polish remover, aroma enhancer in foods and perfumes, manufacture of paints, varnishes, solvents, inks, etc., and it's produced by the reaction between ethanol and acetic acid, which yields ethyl acetate plus water. Now, answering the first question, we had to calculate for 1 ton of ethyl acetate how many grams of ethanol and acetic acid would be needed. Here are the procedure done to convert from 1 ton of ethyl acetate to each of the reactants. And based on the theoretical yields obtained above, we can conclude that producing 1 ton of ethyl acetate does not require the same amount of reactants, as the masses needed of ethanol acid differ significantly one from another. The limiting reactant in this reaction would be ethanol, requiring only 5.23 to the power of 10 grams to yield a ton of ethyl acetate. On the other hand, 7.4 to the power of 10 grams of acetic acid are needed to yield a ton of the product.
Okay, so here in question number 2, we have that the company has a certain amount of ethanol and acetic acid in inventory, and it's asking us to calculate the amount of ethyl acetate that can be produced. First of all, in both cases, we have to convert from liters to mass. That's why we multiply 500 by the densities of each compound. Then we proceed to make the stoichiometric calculus that we learned during this course, and we can conclude that the ethanol is a limiting reactant here, and thus the company can only produce 754.49 kilograms of ethyl acetate.
Could you explain if the production of ethyl acetate can be increased by removing the water from the following reaction? So first off, let's remember how it's produced. It's produced from the condensation reaction of acetaldehyde in the presence of aluminum alkali oxide, acting as a catalyst. This reaction takes place in the series of continuous process barring cold, perfect mixed reactions. So to increase the production of ethyl, we'll first have to act negatively on the balance equation by distilling the solution. This will end up with the water shifting right and leaving us with a higher increased ethyl acetate solution.
So we now know that removing water will be helpful to increase the production of ethyl acetate. So how can we do this? Well, it's important to take into account Le Chatelier's principle that we already saw. So there will be the water shift to the right in the process to eliminate the excess water. So something we could do to help along with this process is using some sort of drying agent, such as sodium sulfate, which will extract the water from the organic reaction.
Do you think there is another way to favor the production of ethyl acetate? According to Catelier's principle, changes in temperature are the ones that will change directly to equilibrium conditions. If the temperature increases, the equilibrium position will move in such a way that the same temperature will decrease again. For example, if it rises from 200 degrees Celsius to 300 degrees Celsius, it will drop back to its original temperature of 200 degrees Celsius. This works the same way in rivers, so we think that if you increase the temperature by heating, it will remove the water, making the production of ethyl acetate more effective. So I think yes, if you increase the temperature, may favor the production of ethyl acetate.
The concept of green chemistry, and according to the United States Environmental Protection Agency, green chemistry is defined as the design of chemical products and processes that reduce or eliminate the use of generation of hazardous substances that applies across the life cycle of a material product. On the other hand, we have remediation, and remediation removes hazardous materials from the environment. The difference between these two is that green chemistry keeps hazardous materials out of the environment in the first place, and remediation removes it, like the ones that are already on the environment. Ethyl acetate and green chemistry. How can it be applied in chemical processes to meet the green criteria? Well, first of all, ethyl acetate is easily degraded in water and air compared to other solvents, and it is a greenly and highly efficient solvent. What is a green solvent? Well, green solvents are environmentally friendly solvents that are the key to carry the majority of chemical processes without severe implications to the environment. And it is less toxic when exposed to humans compared with other solvents.
Since ethyl acetate is a greener and cleaner solvent, it can work to replace other more toxic ones, such as chlorinated solvents, petroleum, and hexane. Some of its main uses is it works as a coating solvent for paints, lacquers, and varnishes, such as like nail varnishes or any type of paint. And it could also work as an extraction solvent, and we can see this in processes such as the decaffeination of coffee or tea.
Now, briefly explaining what kinetics are. This is the evidence that explains the mechanisms of chemical processes, which will tell you what is the most effective way of causing a reaction to occur. Now, for question 1, how can you estimate how fast would ethyl acetate be produced? In real cases, like the one presented in the problem situation, knowing whether a reaction can occur will not suffice to solve the issue presented a few slides back. That's where chemical kinetics enter. Speed of a reaction is given by the reaction rate, a measure of how fast reactants are consumed and products are formed. Here we have the 0, first, and second order reactions and their corresponding graphs. As to know the reaction rate of a reaction, first you must know the order of it, as I mentioned above. So with a given data, you have to analyze which graph best fits experimental data, which is just a single way of knowing what the rate is. And this will make it easier to calculate the equation of it, as it will tell you K being the slope, and the rate will depend on the slope and the concentration of the reactant at a given time.
Is there any way that the ethyl acetate production process can be speeded up? An efficient way to accelerate the process of ethyl acetate can be through catalysis for chemical reactions. The function of catalysis in chemical reaction is to increase the speed of the chemical reaction by reducing the energy of the transition state and decrease the energy activation or changing the reaction mechanism.
And as a final reflection, I would like to say that everything I learned in this course is something that will help me a lot in my personal development and in my next semester, since I will be doing my internship in the lab. And I think it's really important to understand these things in order to understand the topics I will see next semester. Not only that, but chemistry is something that is present in our daily lives. It is something so simple, but it has a lot of importance as well as the example we saw in class with the acids and bases and the fish and the lemon. And in conclusion, to summarize everything, I personally, for me, this class was one of my favorites, and it was thanks to the teacher and my classmates who made it so easy for me for explaining me and everything.